Hi everyone. I'm sorry to pull you back. I think quite a few groups were still working through the core section of that exercise, so don't panic if you haven't finished that. What my recommendation would be is that I'm going to go through some interactive plotting stuff now. This is part of session 3C, the one that was meant to start just after lunch. I haven't managed to pace this correctly, I think. I know that a couple of people, or a lot of people actually, are really struggling to keep up with the Python section today. There's a lot of Pandas stuff that we're recovering that isn't, well, that I'm not covering perhaps in as much depth as would have been helpful. And there is a lot to take in. So what I would recommend is for those groups that are still working through the core section of the previous exercise, when we go out into the groups to do this interactive plotting exercise, carry on with the previous exercise. Don't worry about the interactive plots, just focus on getting your static plots sort of down pat. That's probably more important right now. The interactive plots for those groups that were already getting onto the extension or the challenge, I'm going to go through the interactive plotting section now. And I think hopefully it will be useful for everyone to see what the interactive plots sort of roughly look like, what's achievable with them, what might be easier in interactive plotting and what might not be. But you don't have to know how to do both kinds right now. It's absolutely fine to just be able to do static plots or just to do interactive plots. If you look at this and go, wow, this looks way easier, then just focus your efforts on one or the other. It's that's absolutely fine. So with all that said, interactive plots. So very often a static plot is a really good way to display your geographic data because you have complete and utter control over the final output and what you're going to be highlighting to your stakeholders. And you can, what we haven't really covered so far yet, but there are some additional slides on, is inset maps. So actually, if you've got this wider map and you want to zoom in on a small region, you can start to provide these additional zoomed in plots within the main plot figure, etc. But what if they're actually interested now, instead of looking at Exeter over here, instead of they want to look up at here or wherever this is, are they going to come back to us and ask us for yet another map and so on? Well, an interactive map is going to allow you to zoom in, zoom out, move around, hover over and see things. I may not have shared the video, so if this isn't working very well, then do shout and I can reshare my screen. But basically, you'll be able to move around and see what's going on. You'll be able to change the zoom level. You'll be able to zoom right into the areas that are interesting you. You can do this with point data as well as with choropleth data. And it's a very powerful option within Python. Now, on the web, most maps are created using a JavaScript library called Leaflet. So you may see references to Leaflet sort of here and there when you're looking at code related to interactive mapping. But the Python library we use is called Folium. It builds on it's basically a bridge between Python to this Leaflet interactive mapping library. So it makes our lives easier to create these interactive maps. So the first thing we need to do is import Folium anytime we want to create a new Folium map, and then we create a base map first. So what we need to pass in is the starting location. So we're working with, 55, as our sort of central point. 55 is our latitude, our sort of vertical section. -3.5 here is our kind of our longitude, our sort of central starting point somewhere in the middle of the UK, effectively. We're saying that we want to start at a certain zoom level. So here, again, you might want to fiddle around, but these settings will give you a nice map that starts pointing at the UK. Tiles, so this is the base map. This is just what base map is it looking at behind this? What are we looking at? Google Maps? Are we looking at OpenStreetMap? That sort of thing. The default for Folium is called CartoDB Positron. Don't know why it's called that. If anyone does know, please pop that in the chat. But effectively, we create this base map and save it to a variable. So here I've called GP map interactive because I'm going to be adding some data about GP surgeries to it. And then we go in to, if we run the code cell, or if we run the line GP map interactive, it will make this interactive map show up for us. Now we can change the zoom level. So here zoom 5.25 starts us out with a very big zoomed out map, showing a bit of Europe as well. If I change the zoom level to 7, you can see that without changing the location, suddenly where my map starts when someone will load it up has changed. Same, we can change the location without changing the zoom between these two examples. So now by changing the location, the start point to the start central point of my map to 51.5, I haven't changed how far over it is, I've just changed how far up it is. Then you can see now we're focusing more on the south of the country. Quite nice here, you can easily change between different tiles. That's a lot simpler than in some of the other methods we've looked. So you can pass in OpenStreetMap, you can pass in CartoDB Positron, you can pass in CartoDB Dark Matter. There's a couple of different options available. Those are the 3 core ones that are easy to load in. And all you're doing there is when you create this interactive base map, you pass it in as an argument with one of these 3 strings. Now point data inside a geodata frame, inside a Folium map. The first thing we need to do, so what I've done here, going back to my data sets before, I've got a GP list. I've got a list of all GPs in the country and the size of the number of people on their list. I have set, in this case, we're working in latitude and longitude, not northings and eastings. I've set my minimum and maximum extent of my data set, so I'm only interested in the southwest, and I have filtered down to just this area. Now, just a reminder as well, .cx here isn't contextually. This is unfortunately named the same, but it is a method of the geodata frame. It's just saying, I believe it's something like cut at, cut coordinates, something like that. So please cut my geodata frame down to these coordinates that I have set. My x-axis is my longitude, my y-axis is my latitude. You're just passing this in to cut down to a certain area. Then we have created this base map, nothing on it yet. So you're kind of seeing that this is a slightly different way around to what we're doing with matplotlib. There we create our map and then we add a base map to it. Here we start with our map and then we add points to it. What we do is first we run this line here just to filter out any instances where there is no geometry. If we try and add empty geometry to this map, we'll probably run into an error. What this line is saying is please take my geodata frame, GP lists geodata frame southwest, which I created up here by filtering my original geodata frame, and please remove any instances where the geometry is empty. So it's basically saying filter out instances of empty geometry. That's all that line is doing. You can use that same line, just change out for your own geodata frame. The next thing we need to do is create a geometry list from the geodata frame. So we're providing a list of coordinates that we will iterate through. So we're saying, I want this GP surgery as at this location, this GP surgery is at this location, and so on and so forth. We use a list comprehension to do this. Again, all you need to do when you do this for your own data sets or the data sets in the exercise, you just change this little bit out here for your own data frame. You can just follow the same pattern. But what it's doing is for each set of coordinates within this data frame, it's looking at the longitude and the latitude. It's pulling those out of the data frame. What we then do is we go through that list of coordinate pairs and say, please add a marker in each of these locations with the coordinates I have provided. So for each pair of coordinates within the list we've created here, please add it onto my interactive map. We can pass in a custom icon really easily within this. So on the website Font Awesome, there are a series of free icons available that you can choose from. Here, what we've done is said, please use the icon is called user MD, just gives us a nice doctor icon. The prefix here refers to Font Awesome, the library of icons we're interested in, and we've said, please make my markers black. Now, all you need to change there is go to anything on Font Awesome version 4 icons. So if we load this up, I'll pop the link in the chat afterwards, then you can go through and find any icon that looks interesting to you and pop that into your Folium. You can also create a marker from a file that you have on your computer. Now, all that's different about this is we use the Folium features custom icon method. And what we're doing here is we are creating the icon each time within our for loop. So when we're going through our list of coordinates saying coordinate 1, please place this doctor's surgery here, coordinate 2, please place this doctor's surgery here, we have to create the icon each time within the for loop. It won't work if we don't make it inside the for loop. It's just a little quirk of the way Folium works here. But all I've done is point towards a PNG icon. This could be a PNG, it could be a JPEG, any sort of image file, an SVG. You just want to point towards that, which is wherever it's stored in your computer, this file path here. We set up how big we want the icon to be, the icon size, and then we go through and we say, please make the icon equal to this icon that we've set up here. Tooltips, again, so tooltips are what will appear when we hover over like this. So the here I've hovered over a particular surgery, and what I've got is a tooltip showing the name of the surgery and how many people are on their list. So all of this is what we had previously. We've set our extent, we've filtered down to this extent, created a base map, filtered out instances without geometry, created our list of points. Now, all we're changing is the for loop slightly. So we're saying for our geodata frame list, we're using this argument called enumerate. So what that means is instead of just giving us the items from the geodata frame list, instead of just going, okay, here's coordinate pair 1, coordinate pair 2, coordinate pair 3, coordinate pair 4, I will be 0, 1, 2, 3, 4. Coordinates will be our coordinate pairs. Now, this is quite helpful because we can then correspond that back to our geodata frame and a row in our geodata frame. So all I'm saying here is please add the marker and please add a tooltip looking at our geodata frame. Look at the name column, which here is one of our GP surgeries. Please look at item row 0. Please format it a little nicer, so that title case, we're just giving a capital at the start, lowercase at the end. And then in the next line, please give me the list size. Please give me how many people are on the list. So again, we're looking at that same row of our data frame, row 0, and then we'll go through and we'll go to row 1, coordinate pair 1, and we'll make our new interactive marker, coordinate pair 2, row 2, etc. And we just iterate through like that. It will be looking at the right row and coordinate pair throughout. Now, one other thing to note here is you'll notice there's a little square bracket or sort of brackets like that, pointy brackets, and BR. So a minute ago we were talking about \n, that's the new line character for a lot of things. When it's web-based, BR just means break, it means line break. So it will mean that we have a new line between these two bits of information. Now, the other things you can do within Folium, you can start to import a range of plugins that are available. So you can make a heat map. This is almost identical. The way we get the coordinate pairs is unchanged. The way we set up our base map is unchanged. All I've done is call it heat data this time. And then we use the heat map plugin to pass in this heat map data, these coordinate pairs from our geometry, from our data frame. We set how wide we want the radius of each point to be and how much blur we want between the sections. I'll show what the impact of those is in a moment. We then just add this to our GP map, and now we've got a heat map. Now, I know a few of you are making heat maps in QGIS, and it can be quite clunky in there. This feels a lot easier. Now, changing the radius and blur parameters can have quite a big impact. So here we've just changed the radius, and you can see that the data is unchanged, but the impact of you would start to think certain areas are much busier based on what this radius parameter has changed to. And zooming a long way out can also just turn it into a bit of a mess, regardless of your settings. So just be aware of the starting zoom level that you pass to people when you want to give them this map to look at next. This will kind of not give them the best first impression. So we can also create choropleths in Folium. This is not the most fantastic example because, again, we've got these areas where the vast majority had very few bicycle thefts, but a couple of our areas had higher ones. Generally see it more in cities. That's where these interactive maps really come into their own because you can zoom in and out and go just to the area that is of interest. Now, choropleths are a little bit more complex, so do bear with me here. There's a few steps that we need to do. We create our base map individually, just as before. That is unchanged. We now create a new object, a new variable called choropleth, and this is a folium.choropleth object, effectively. We pass in our geodata. In this case, it's a column of LSOA crime figures, and this needs to be the one that contains our geometry, our details of the outlines of our objects. The data frame, that can be a normal pandas data frame as long as there's some column in common with each other. It can also be a geodata frame. It can even be the same geodata frame that we were just using. So actually we can pass in, as we've done here, the same thing to both arguments. It just needs to know where's my geometry, where's my data, and if it's in the same place, well, I still need to know where both of them are. What we then say is we pass in the key. So what area are you interested in? Here we've got our LSOA 11, so with our 2011 LSOA boundaries, the name of those, but I'm interested in bicycle theft. That's the second thing I'll pass, is I want to plot bicycle theft. I want to pass in the field that links the two data frames, and actually this is a slightly funny one. It's just the string that relates to the column that is shared between the two. But it will always be a string that says feature.properties, column that is shared between the two. These bits at the bottom, these last 1, 2, 3, 4, 5, 6 things, our choropleth would work even if we just stopped here. We basically just passed in what data is it and how do we join up any data that exists. Now we can start to pass in the things that make it nicer, like the fill color, how opaque or transparent our choropleth is, how thick the lines are between each area, the line weight, the name of the legends. So I know we had a lot of trouble getting the legends to have nice names in QGIS. This solves that problem in one line. Whether when you hover over each LSOA, you can get details about that LSOA. So whether it automatically comes up with a pop-up telling you the values that are being plotted there. And the smoothing factor as well. So smoothing factor equals 0 just means don't simplify my boundaries. Don't make them smoother, because actually quite often you don't want that. However, if you do want them smooth, then actually it will probably tend to make your resulting map a little bit smaller in file size, which might be good if you want to send it around to people. Finally, all we do is add it to our base map. So we create our base map, we create our choropleth layer, and then we add our choropleth layer to our base map. And finally, we display our map. You can also add in additional tooltips here. So once you've created that, you could, oh, sorry. So actually, yeah, this just shows that actually it will highlight, sorry, I'm tell a lie about the tooltips here. This highlight equals true just means that when I hover over it, it will highlight the edge of that LSOA that I'm hovering over. To actually then add the tooltips, you need to make sure that highlight is set to true, but then we go through and say, please add to my choropleth a child layer and a layer that belongs to my choropleth layer. And this is going to be a tooltip. And I want you to show the LSOA name, and I want you to show the number of bicycle thefts there have been, and please show this up as a label. So what you can see then is we can just keep adding more and more columns. If there's additional columns in our data set that we haven't plotted, we can just keep going through and adding more. And here now our tooltip shows both the bicycle theft numbers and the total number of crimes. Finally, we can save our Folium maps as an HTML file. This gives you a standalone file that doesn't require Python, doesn't require anything else. It's a fully interactive map that you could just email out to someone. They don't need Python to interact with it. When you add a lot to a map, the file size can become quite unwieldy. So do just have a look at this. 4,000 kilobytes, that's about 4 megabytes roughly. You're probably looking at trying to keep things under about 20 megabytes if you're sending them out to people attached to an email. But if you're storing it on a network drive of some sort, that's a bit less of a problem. But again, very big maps can just start to slow down. We've seen a lot of slowdown today that I'm going to try and fix for next session. Now, Folium does have a range of plugins that are available that allow you to do additional things that aren't supported by default within Folium. So every time we want to load Folium plugins, we basically, well, I won't talk through that here because this is beyond the scope of the main session, but do take a look at the plugins that are available in this link, and I'll just show you some of the ones that are useful potentially to whet your appetite for what you can do with these maps. You can use the dual map plugin to actually show two maps side by side. You could have different things on these maps. So you could have a choropleth on one, points on the other. You could have two different choropleths showing two different things. You can zoom out and move around of these independent of one another. You can very quickly add a full screen icon to your Folium maps. This just adds a button in that will make it so that your user can make it full screen. You can also add in the geocoder plugin. This just allows your users to actually type in any address or similar, and it will zoom into that section. The tag filter button, if you've got categories of data, so say you've got points relating to GP surgeries, points relating to dentists, points relating to police stations, something like that, you could make it so that you can actually filter in and out one of these. You can just show one at a time, you can show several categories at a time, and so on. Finally, the time slider choropleth. This is a really interesting one that if you have some sort of time element to your data, you can add in a slider that will allow people to move through the to interactively see how the data has changed over time. So on to creating some interactive maps in Folium. As I say, if your group didn't get to the end of static maps, then I would recommend continuing on with that. However, if you all sit there and go, these interactive maps look so much better and I much prefer how this is set up, then do feel free to jump onto those two. But my personal recommendation would be stick with the static maps. You can use static maps for everything else within the remaining exercises today and next week. And you can always come back to interactive maps at a later date if you so wish to. The other thing, so I'm just going to go through the questions and see what is being requested, any questions that have come through. So, so then we've got those are from previously. We have a nice link to the some information about what the different the different base maps are from a sim here. We've got a question from Jin about whether this can be integrated with Streamlit. Yes, it can be. You can absolutely use Folium with Streamlit. Again, it starts to get a bit unwieldy with big data sets. But yeah, you can actually do this. And as Dom is saying, you can also use, you don't necessarily need Streamlit or Shiny. You can use it with those, like an actual full-on web app that's hosted somewhere. You can also package it just straight into an HTML document. So you could integrate with this with text, with data frames, anything you want, additional graphs, all in a standalone document that will be packaged up and sent out without needing to worry about web hosting, anything like that. It's just a standalone document that can have an interactive map in it, and we will cover Quarto later in the course. So what else do we have? Folium uses the print function. So yep, as Dan says, you can use f strings anywhere that there is a string. You can always, it's really useful to make use of f strings to integrate your text and any variables. You can use this in, to update what your file names might look like, what your titles within plots might be. F strings are a really nice, powerful tool to get comfortable with. Question about Folium imports. So Dan has answered that one in the chat. Can you use Folium for interactive plotting of stuff that's not maps? Very good question, Maya. I'm not actually sure. It's not something I've come across. You can use the Plotly library, would be my recommendation for plotting stuff that's not maps by and large. So Plotly is a really nice library for interactive graphs in general, has a lot of the same benefits of your users being able to hover over something and see, for example, how, if you've got a bar chart, what's the exact value of that. They can zoom into regions of a plot and so on and so forth. Is there a way to ensure the map generated is closed source, e.g. intranet and not public? And I'd also be interested to know this. Can the data be held locally so the patient identifiable maps can be produced for services? So my understanding is nothing is going up to the web, but I will seek to confirm that for sure before we talk about patient data. But my understanding is that is not an issue and actually that everything that you're creating is just held locally. You're just using things like Folium to actually generate this. Is Plotly covered on the course? And Maya has asked, I have covered a little bit of Plotly in some of the revision sessions, just because I find Plotly can be a little bit easier than Matplotlib for simple things like bar charts. I will try and include a little bit of Plotly at the end in the modern analytics section if we do have time. But other than that, I can definitely recommend looking up Plotly Express. I will try and look for a link to that I can share in the chat later. Plotly Express is a really nice introduction to the Plotly library that makes it super simple to create most chart types. So you can work with your pandas data frame, and actually creating a bar chart is as simple as going, please take my data frame, I want this x-axis, I want this y-axis, and you have a lovely, nice looking interactive plot that is straight there and ready to integrate or save and send out to people. So it's a really, really nice little bit of kit to have. Right, I'm going to stop sharing there and pause and put you back into your breakout rooms. And I will see you. We're going to work on, we're going to have another 25 minutes now to work either finishing off that other exercise and then moving on to Folium if you have completed the core part of the previous exercise. So see you shortly.